Students and friends, welcome to my YouTube channel. Today we are going to discuss the deflection of beam theorem and respective problems we'll solve. So before discussing this deflection of beam for simply supported beam and load is acting in the center, so some basic concept I will discuss. Then we'll derive this derivation. So what is basic things here? Theory of bending equations, this also derivations will be there. We discussed in this previous video. So theory of bending equations, what they are telling? M by I is equal to E by R, where M is the bending moment, I is the moment of inertia, E is the Young modulus, R is radius of curvature. And theta is slope, dy by dx, or also you can say tan theta. This is called slope. And Y is deflections, what the deflection, the Y I shown here. So Y is deflection. So bending moment equations will be EI d square by dx square. This is the bending moment equation. How this equation is coming? For this will little small one derivations I given. So already we know radius of curvature. We are studying in the math in +2 like radius of curvature. What is equation? 1 plus dy by dx power square and whole square by 3 by 2 divided by d square by dx square. So here we are seeing deflections will be very small. If any beam, if you apply the load, deflections will be very, very small. Like deflections will come 0.01 or 0.02, like this deflections will come. If deflections will square, 0.02 square, now this value will come again 10 power minus 4, very small value will come. This value will come very small. So we are assumed that deflections will be almost zero. Deflection will be almost zero when we are applying the load on the beam. So you substitute here R is equal to dy by dx, this will be 0. So it will be 1 only. 1 power 3 by 2 is 1 only. So 1 by R we are getting here d square y by dx square. Now we'll take this equation, bending equations. Already we given here equation 1. So bending equations, we substitute this 1 by R. Substitute the 1 by R here. D square y by dx square m by EI. Now if we'll take the m is equal to EI d square y by dx square. This is the bending moment equation. This is the bending moment equation. Based on these equations, we are going to derive one theorem. Deflection of a simply supported beam carrying a point load at the center. That only we are going to derive. What will be the deflection and what will be the slope will come. That we are going to derive. So I will write that questions here. I will write that questions here based on this bending moment equation. So how this bending moment equation came? For that only I did this. Okay. So now I will write those questions here. What will be the questions here? Derive deflection of simply supported beam. Derive deflection of simply supported beam carrying a point load. This is the point load. Carrying a point load at the center. Then what will be the slope and deflection? So derive the deflection of simply supported beam. That means we have to derive the slope and deflections of the beam. What will be the slope and deflections of the beam? So now we are going to derive here. So this bending moment we will use when it will work. So now see this, what is the derivations here. So first we will find the support reactions for the A and B. So in this point support reactions will calculate. So how to calculate the support reactions? Already you know the equilibrium equations will use. Summation of FB equal to 0. That means total upward force equal to total upward force equal to total downward force. That means RA plus RB is equal to, this is the W, only one load is acting, W. Give the equations number 1 here. Then we will take moment about A equal to 0. That means clockwise moment equal to anti-clockwise moment. Total clockwise moment equal to total anti-clockwise moment will take. So moment about A is fixed. So W into L by 2. What will come first? W into L by 2. Then RB into, this is W into L by 2, clockwise movement. Now another force will be downward here. So this is anti-clockwise movement. RB into L. RB into L. RB into L. So what will come here? L will get cancelled. RB is equal to W by 2. If you will substitute in this equation 1, W minus WL by 2, so RA also will come W by 2. So we find the support reactions RA and RB W by 2. So support reactions I got it. Now we will take any one section. I am taking one section here X. Taking one section here XX. Now we will find the moment of this MX. What will be the bending moment of RA into X, RAX minus what will come here? So it's equal to W by 2 into X. Yes, it will come. Taking moment about X, no? So it will come RA into X equal to RA how much? W by 2 into X. This is the bending moment. Give the equations number 2. So we got this equation. Now we will calculate. Now we will calculate slope and deflections from calculate slope and deflections from bending equation. From bending equation. So bending equations, what is, we know the bending equation is, that is what is bending equations we derived before. I wrote there EI d square y by dx square. This is called bending equation. Bending equations. What we derive when that I told this bending equations required for this derivation. So we wrote the bending equations. Now M is equal to this. What is W by 2? Substitute here. M is equal to W by 2x equal to EI d square y by dx square. This is called double integration method also. This we are solving, finding the slope and deflection by the double integration method. Also some other method will be there, area movement method, another one or two method will be there. So first we are discussing the double integration method. So now we'll integrate both sides. Now we'll integrate the both sides. So right here, integrate both sides of bending equation. Bending equation. So we'll integrate here. So W by 2x dx equal to EI d square y by dx square. So this is the bending equations here. Okay, so integrate. So W by 2 as it is, x integrations x square by 2 plus C1 is equal to EI d square y by dx square, integrations will be dy by dx. So how this coming? Suppose the integrations dy by dx. This is dx, you can write. So this is nothing but d square y by dx square. So as we know the integration and this is differentiation, both are inversely proportional. So what will be there here? dy by dx. This is the integration for this. So now this will give equations number 3. So now what we'll do, we'll apply the boundary condition and we'll make this dy by dx 0. So when will be the dy by dx 0? So just little explanations required here. See here. In this point, this is AB is the beam. Now what is the deflections of this? This is the curve is deflection. So deflection is started from x. Deflections will be, see this, deflections will be here 0. Y is equal to 0 at point x. Deflections will be 0 at point x equal to L. But slope will be maximum. See here, if we draw slope, how we are drawing the slope? Suppose this is the curve here. This is the tangent. This is the slope. If if we'll draw the tangent here, slope will be 0, but deflections will be maximum in this point. When x equal to L by 2, deflection will be maximum. When x equal to 0, deflections will be 0. When x equal to L, deflections will be 0. That means both end deflections will be 0, but slope will be theta A, theta B, both will be maximum, both in the point. But deflections will be maximum where? In the middle. Deflections gradually increasing. But deflections at point X, X point Y, X point A, X point B will be 0. So this deflections when will be 0? So let us substitute our boundary condition. Boundary conditions for this equation. So dy by dx will be 0 where? At point x equal to 0. If x equal to 0, deflections will be 0. So that will substitute here. That will substitute here. So we'll get the deflection equation, then we'll get the deflection. So substitute in equation 1. So what will come here? This part will come x equal to 0 now. This part will come 0 plus c1 equal to x equal to deflections will be 0. So x equal to L by 2. Yes, here. So because we are taking deflections, not slope. So we need that this is dy by dx is nothing but here what is? Dy dx nothing but slope. So we have to make slope equal to 0. So slope will be 0 where? Slope will be 0 when x equal to L by 2. Slope is maximum here. Theta is nothing but slope. So slope will be 0. So here little changes, w by 2 into L square by x equal to L square. So 4 into 2, 8. X square means L square by 4, 4 into 2, 8 plus C1. So here will be 0. So it will come C1 equal to, that implies C1 is equal to minus WL square by 16. So this is one conditions we got. So this substitute this value in equations 3. Substitute C1. Now you write here. Substitute C1 in equation 3. So what will come equation 3? So W by 2 into x square by 2 minus, what is C1 here? WL square by 16 is equal to EI dy by dx. This is come slope equation. This is known as slope equation. This is known as slope equation. So we got the slope equations now. WL square by 16. So now what will be the maximum slope? So now we know we need the maximum slope. Maximum slope will be where? Where y is equal to, maximum slope will be there when x equal to 0. So we'll substitute here x equal to 0, x equal to 0, then theta A will be maximum. Theta A will be maximum. What is theta A here? dy by dx theta. So we are taking at point A or B, what both will be same, theta A or theta B. So theta A will be maximum. Now we'll substitute this in equation. This you give the equations number 4. Now we'll substitute this in equation number 4. So now we'll rub it here because this equations is asking generally. So the equations will be long. So we have to derive fully equations. Okay. Now we'll substitute this EI theta A. So that implies EI dy by dx. So taking point A side. So this will write theta A equal to what is there? This equations Wx square by 4, x equal to 0, no? X equal to 0. So this part will come 0. 0 minus WL square by 16. WL square by 16. So finally theta A is equal to minus WL square by 16 EI. So what we are getting? WL square by 16 EI. That also known as theta B. So both point A and B slope will be this WL square by 16 EI. This is the slope we got where for the simply supported beam we are carrying the central load. So this is the slope. This is the slope. So sometimes a problem also they will ask na, this formula itself remember it will be enough. Okay, so find the slope and slope at point A, point B. So this formula will substitute, we will get the answer. So negative sign indicate the slope is downward of the beam. That is meaning here. Now we need the slope over now deflection. So again we will integrate equations, this one, equation 4. Again integrate equation 4. So what is integration sum 4? So both side will integrate. Integrate equation 4 both side. Both sides. So what will be the integration here? So W by 4 x square 2. So W by 4 you take outside, integrations x square by x square dx equal to W over x dx. Okay, minus also there, not just one times you write it. So what is the equations here? Integration W by 4 x square dx minus WL square by 16 dx equal to EI dy by dx. I wrote this first. Now we will integrate. Okay. Now we'll integrate this. So what integrations will come? So this you bring this side. EIY. What is dy by dx integration? Y. Now W by 4 as it is x square by 3 minus WL square by 16 as it is x plus C2. Some constant will take C2. So E by I, W by 4 x is cube by this x cube by 3. So x square no. So x cube by 3. Then WL square by 16 constant. Dx integration is x plus some constant C2. Okay. Now substitute here. Y is equal to, we have to make 0. So y is equal to 0. That means here deflections will be 0 at point A. Then at point A x equal to also 0. So make the y equal to 0. That means this is the deflections here. Deflections is maximum when x equal to L by 2. Deflections is 0 at point A and B. So at point X. Now substitute this boundary condition. This is boundary condition. If you substitute this boundary conditions is equations 5, then what you will get? If substitute the boundary conditions is equation 5, we will get this one equation. So that implies EI into 0 is equal to W x equal to 0. So this also terms will come 0 minus 0 plus C2. So that implies C2 is equal to 0. So here what will get? C2 is equal to 0. Now C2 is equal to 0 will substitute in equations 5. Substitute C2 is equal to 0 in equation 5. What will get? EIY is equal to W by 4 x cube by 3 minus WL square by 16x. This is the equations of, give equations number 6. This is called equation of Y. Y is what is deflection. Equation of deflection. Now we'll got the maximum deflections will be where? Where will be the maximum deflection? Where x equal to L by 2. That boundary conditions will substitute now. When x equal to L by 2, we'll get the maximum deflection. When x equal to L by 2, we'll get maximum deflection. That is called Y maximum. So y, when substitute y is equal to y maximum, that will substitute into y. So x equal to L by 2 will get the maximum deflection. So EI y maximum equal to W by 4 L by 2. So first 1 by 3 you take, L cube by 8, because 2 power q 8. 1 by 3 taken outside. Now minus WL square by 16, x equal to L by 2. So L square by 2 to 4. 4. So this now will solve here. So how much will get here is check. 8 या 24, how much coming? So 24 into 4 is coming 96. W by 96 L cube minus WL power 4 WL square, x equal to, here x only, no? This is wrong here. Here x is equal to what is L by 2 only. L by 2 only. W square by 16. Check it again. Y is y maximum. W by 4. X cube na L cube by 8. 3 here. WL square is 16. X equal to L by 2. So 32. WL cube by 32. Because once L cube come in here should come L cube. So L4 na something wrong. So this way you have to check always. Now we'll subtract here. What is the equations here? So LCM will take 96. So here WL cube minus 32 into 3 times the 96. 3WL cube. So finally what will come? 2WL cube by, this will come negative because 3 more value, so 96. So minus WL cube by 2 into 2 is 48. So WL cube by 48 we got here equal to what is EI y maximum. EI y maximum we got this. So now finally what we are getting here, y maximum, that is deflections will be maximum when x equal to L by 2. So what is the maximum deflections here? Minus WL cube by EI 48 or 48 EI, right? Like this good only, 48 EI. So this is the equations for the maximum deflection. This is called the maximum deflection. This is equations for the maximum slope. Maximum slope will be at point A and B. That objective questions will be there. If simply supported beam with the load is acting in the middle, where the maximum slope will be at point A, at point B. And what is the maximum deflections in the center? What is the maximum deflection? Minus WL cube by 48 EI. This is 48 EI. I is moment of inertia, E is Young modulus, W is load, L is length, total length. So this is called minus WL cube by 48. Negative signs, what it indicates? Deflections will be below the lines. Okay. So this way we can solve this derivation. So here like this derivations will be there. What is? Simply supported beam, load acting in the center. Then UDL, simply supported beam with the UDL. Then will be there cantilever beam for the point load, cantilever beam for the UDL. So 4 derivations once will know. So based on these questions we'll solve now. Generally like these questions will coming and the derivations, directly the derivations also asking in the questions. Okay. So make this, make sure how to revise and go the beginning to end 2-3 times practice. So these equations will get what is deflections and slope of this particular beam. Okay. Okay, students, thank you. Watch the video and subscribe the channels. Okay, thank you.